All right, well, happy second semester. Here we are embarking on our second half of calculus. The first half, of course, we did derivatives and applications of derivatives, and we're kind of embarking on our second half, and that's integration or antiderivatives. So let's jump in and get ready to roll. So if I told you that some dude has a derivative of 3x squared, well, who is that? Who possibly could have 3x squared as their derivative? You'd say, well, I mean, if I did x cubed, f of x could be x cubed, which, yeah. Can you think of another one that would have me that same derivative? Well, you said, okay, I could do x cubed, but I could slap a plus 5 on there. Or I could do x cubed minus 7 on there. Well, I could do x cubed plus any constant. I could have any number there. And that's the point, is that you have this plus c, this constant, that c could be any constant, plus 5, minus 7, plus 1,000, minus pi, whatever the case may be. And so this question is kind of written in, mathematically and in kind of a sentence form, but with simples, there is something that says the same thing. And this is called indefinite integration. Now notice it says it here that this symbol is called an integral. Okay. It looks like a big S, the reason they picked it. We'll talk later when we do definite integration of why they elongated the S, because you're really just summing up stuff. What is right here is called the integrand. And here's the deal. This and this are bookends. You can't have an integral symbol without having a d something. Kind of like with derivative taking, you have to know what variable you're taking the derivative with respect to. That's the same thing. You have to know what variable you're integrating over. So are you integrating over y? Are you integrating over x? So an integral has to have a d something on the end to tell you you're integrating over the variable x. So this right here tells you that mathematical statement is asking the exact same thing as this right here. When you see the integral, it's saying that somebody has this as its derivative. Who is that somebody? Or in other words, find the antiderivative of this guy. Okay, so the antiderivative would be x cubed. And like we said, you have to have that plus c. That is the constant of integration. And you have to know when you're doing indefinite integration, you always have to put in that plus c. Now, I keep saying the word indefinite integration, and you're like, okay, what's the difference between indefinite and definite? Well, we're going to focus on indefinite for right now, but just so you know the difference, definite integration looks the same right here, but it has numbers. So I'm just arbitrarily picking 0 and 4. It has numbers on the integral symbol. And what you need to know, we're not going to get this number, but when you do definite integration, what you get out is a number. You get out 10, you get out -4, 0, whatever the case may be, but you get a number. When you do indefinite integration, you do get out an expression there. So let's figure out some rules for taking antiderivatives or integrals of things. So let's just look at this chart. Okay, who would have a derivative of 0? So I kind of did it in chart form. Who would have a derivative of 0? Well, any constant, right? So notice, let's kind of put these together. So that means if somebody's derivative is 0 and it's a constant, that means that the integral of 0 is a constant. Now, who would have, if f prime of x is 1, think of who would have a derivative of 1. Okay, well, x would have a derivative 1. That's a possibility. But just like we talked about, I could put any constant with that. I mean, x plus 5 would still have a derivative of 1. X plus 9 would still have a derivative of 1. And you get the idea. So let's see if we can, fill out the rest of that chart. Who would have a derivative of x? Well, it's got to be an x squared, right? But think, if you took the derivative of x squared, do you get just x? You would get 2x, right? So what would I have to do? I would have to multiply by a 1/2 right here. Now, if I had 1/2 x squared, wouldn't the derivative of that guy be x? Yes. So again, all these are going to have you could have a constant as well. I'm just trying to get I'm trying to get and develop the rule, the power rule for integration. So let's keep going. Let's see. For x squared, well, I'd have to have x cubed, but once again, that would give me a derivative of 3x squared, but I don't want 3x squared, I just want x squared, so I'd have to slap a 1/3 in there, and hopefully you're seeing the pattern. So what does the rule become? If you have x to some power n, you have x to the n plus 1, but then you have to divide by that new power. And of course you have the plus c. And what we've just done is we basically have our some integration rules. Really and truly, they all come from this one, and that's the one we just talked about. What is the rule for x to the n? It's going to be, whether you put that n plus 1 in the front, like as a fraction, sometimes I write it like this. It just depends. You know that those two things, how I wrote it here and here, are the exact same thing. And so I associate words. You know that I'm a wordy person. Is that what I did was increase the power by 1. And divide by new power. So that's the power rule for integration. And these other ones really are derived from that, or come from that. When you look at this guy, what is really, this one right here, sorry, you can't see where I'm pointing. When you have just the integral of dx, well, what's really there? Well, it's the integral of 1. This is why the whole dx thing is important, because if I ask you for the integral of 1, that's really 1x to the 0. Well, you told me what that answer would be. It would be x plus c. However, if I had the integral of dt, I wouldn't put x plus c. I would integrate 1 with respect to t, and I would put t plus c. So that's why, again, that bookend, that's what that means. That's how you know what variable you're integrating over. So with any constant, if I said, what's the integral of 5, you would say 5x plus c. With the integral of -6, -6x plus c. So this would be here. Now, as we go through the little more complicated examples, we're going to use this property as well for this first one. It's saying that you can take this 6 out. Now, you're not going to actually write this because you're going to just do it all in one step, but it's saying that I can pull a 6 outside of the integral. I can take constants out. So if I have the 6, now if I want to do the integral of x to the 4th by using my power rule, I'm going to increase the power by 1 and divide by that new power plus c. And of course I don't know why I'm writing it over in pink, just because I'm anal, I guess. And I would get 6/5 x to the 5th plus c. I cannot forget my plus c. All right, now this next one is using this idea. Just like derivatives, when you're separated by a plus, remember how we just kind of went down the line and took the derivative of each one? Well, you can do that with integrals as well. So I'm going to go down the line and take the integral of each thing. And people, I'm going to go straight to the answer because I think you're going to want to do that as well. Look, when I have this 12, I know that I can do this. I don't bother rewriting it. I say this. Well, I'll do it in 2 steps, but I'll increase the power by 1 would be 6, and then I would have 12 over the new power. That 12 just kind of comes along. Now go down the line. I would have the 5, he stays. I would have x squared. I divide by the new power, and that would be 5/2. And then how do I integrate -7? It would be 7x, and then I'd put plus c. And then the last thing for me to do is just kind of do my numbers and reduce. Now again, whether you put the 5/2 or you put the x squared on top and all of it over 2, it's the same thing. So it doesn't matter to me how you write it. And this is going to be my final answer. So like I said, normally as you practice more, you're just going to kind of do that because you're going to combine your constant, and when you do the division, you're going to kind of do it in your head. But that is what you are doing. So why don't you go to the back and try that next example. Don't get confused by the long list. You're just going to go down the line and take the integral of each thing. So here we go. You're going to have x to the 4th, x to the 5th, and your number will be 5/5. You're going to have x to the 4th, and you're going to have 8 over the new power. You're going to have x to the 3rd, 9 over the new power, x squared, 2 over the new power, plus 3x plus c. And of course, you're just reducing. And like I said, many of you probably went straight to this answer, and that's great. Now remember, what I can always do if I'm not confident in myself, notice if I took this and I said, guys, write me down what the derivative of that would be. Do you see that the derivative of this thing with respect to x would be 5x to the 4th minus 8x cubed plus 9x squared minus 2x plus 3, and lo and behold, this and this are the same thing, so I know I have the right answer. That's what you're doing. You are taking the integral, or you are finding, again, what's called the antiderivative of that expression. Okay, so let's look at the other ones. Just like derivative taking, you have to, when you have a quotient, now here's why I say that integrals are harder than derivatives, is because if you have a quotient that you can't rewrite, you had a quotient rule for derivative taking. There is no quotient rule for integration. You just have to figure out, it could be one of about 5 different things, and you have to figure out which one it is. Well, the purposes of right now, all we know how to do is we're going to have to rewrite it. So you cannot just take the integral of the numerator over the integral of the denominator. That is not going to give you the correct answer. Right now, look to rewrite it. So what I mean is, in example 2, I see that quotient and I think, you know what? I'm going to rewrite that as this. So I rewrote 14 over x squared as 14x to the negative 2. Now I can do my power rule for integration. Remember that it's increase the power by 1. So when you do negative 2 plus 1, that's negative 1. You divide by the new power plus c. And of course, you cannot leave negative exponents. So I'm going to rewrite that as negative 14 over x plus c. And that's going to be how I write my answer. So let's try number 3. Again, I see square roots. I'm going to rewrite that as powers because that's what I know how to do. So let me rewrite him. That's going to be the integral of x to the 1/2 plus, now be careful how you write this one. A lot of people mess up because of the rewrite. You're moving the x to the top to write as a power. The 1/2 stays 1/2. So this is how you rewrite that second term there. Now let's do the power rule. Again, I'm going to go down the line. It works with fractions as well. So I increase the power by 1. So 1/2 plus 1 would be 3/2. Divide by the new power. Remember, dividing by a fraction, it's easier to think of multiplying by the reciprocal. So I'm going to put a 2/3 in front. Let's keep moving down the line. I have the 1/2. He's going to kind of stay. I'll clean up. I'll do this in a couple steps. Increase the power by 1. So again, negative 1/2 plus 1 is 1/2. Dividing by the new power. Dividing by 1/2 is multiplying by 2. And then I can't forget my plus c. So my final cleaned up answer would be 2/3 x to the 3/2 plus, those 2's cancel, x to the 1/2, they might write as x to the 1/2, or of course the square root of x, plus c, and there you have it. All right, a few more. Now this one killed us with derivative taking. Remember, I can't do the integral of the top over the integral of the bottom. I see a quotient, and for the purposes of right now, what you have to think of is rewriting. And two, when you get to AP, how are you going to know to do this? Remember, if you see a monomial right here, one term, you just want to do the division. So in other words, what you're going to look at that as is, or some people say, undo the common denominator. Whatever helps you, you're going to do this. So you're going to kind of undo that common denominator, or you're going to do the actual division, which of course, what is x cubed over x squared is just x. And then that second one, I'm going to write this way. Now I'm ready to go. Now I'm ready to do each of those individual things. So increase the power by 1. Remember, there's really a 1 there. So increase the power by 1. So that's x squared. Divide by the new power. That'd be a 1/2 in front. Plus x to the increase the power by 1 would be negative 1. I would divide by the new power. So that's really going to be a negative 2. And plus c. Let's rewrite that without the negative exponents. So 1/2 x squared minus 2 over x plus c is going to be my final answer. And then this last one. The last thing I wanted to do is one like this, just so we'll deal with this later, but I just want you to be very clear. Remember, with derivative taking, if I said, what's the derivative of 3x minus 5 to the 7th? You didn't just say it was 3x minus 5 to the 6th. You had the issue of the chain rule. You had that inner derivative that you had to remember to multiply by. Okay, so we remember that with derivative taking. Well, for integration, there's something that you have to do as well. But I don't want to get into that today, okay, this is our first day. So here's what you need to understand. If you start doing the power rule, if you look at all the examples that we have just done, every single one of the things that you were raising to the power, it was just an x or a t or whatever. The inner derivative was 1. So what you have to make sure of is when you're doing the power rule for integration, if your inner derivative is not 1, you don't know how to do that right now. So on example 5, I can't just go, oh, well, I'm going to increase the power by 1, that would be 3, and divide by 1/3, and this is going to be my answer. Okay, I cannot do it like that. That is not correct because my inner derivative is not 1. So what I have to do now is I have to just say, well, all I know how to do is rewrite. For right now, all I know is rewriting. So what is that really saying? If I square that out, that's 9x squared minus 30x plus 25. Now, if I wrote the question like that, you'd say, well, that's a very simple question. So increase the power by 1 is cubed. 9 divided by 3, you're probably now doing this pretty quickly. It's 3x cubed minus increase the power by 1 is 2. 30 divided by 2 is 15. Increase the power by 1, 25x. Can't forget my constant of integration. And that's my final answer. So now you have done antiderivatives or integrals in definite integration. So practice that tonight, get the rules down, and we'll rock on. All right, peace out.